As he's getting mic'd up, I will give you some clues about his identity. He is a return speaker to the BSidesTLV stage. He is one of our most popular speakers, and I expect this to be a fascinating talk. And he's got a few hobbies. In fact, this morning, he went for a run. I'm talking not about a run command, I'm talking about a run on the beach. Yes, which is quite surprising with this weather. And what else I can tell you about this mysterious speaker that I'm sure many of you already know? I'm talking, of course, about Gal Bitensky. So Gal Bitensky is going to be ready to come. You can come from here, it's okay. Okay, so please give a warm welcome to Gal Bitensky. Running all the way from the other side of the stage. And Gal is going to talk to us about some really, really cool stuff. We're going to learn about leveraging passive fingerprinting for link scanners evasion. What are link scanners? Nazdarovia, salute, kampai. What are link scanners and how do you evade their detection? All that and more by Gal Bitensky. Give it up to Gal. Yay. Woo.
So, yeah, it's working. So, hello everyone, good evening, and welcome to my talk. My goal today here is that everyone in this room will know what link scanners are and how we can use this fingerprinting concept in order to evade it. So, first and foremost, this is all of my social media accounts. I'll greatly appreciate if someone will send me pictures of this talk because my Polish grandma is driving me nuts. So bonus points to anyone who's assisting me with this kind of area. Okay, a bit about myself. Yeah, so there will be a lot of cheap PowerPoint animations in this talk. I am a PowerPoint animation evangelist, but I'm also really into all kinds of malware evasion techniques. I did mostly this stuff for about 4 years, but from there I kind of proceeded into doing more web-related stuff at Akamai, namely bots, mainly. Currently sharing my home office with all of those feline beasts. That's Chewbacca sitting there on my shoulders, actually doing the research you are seeing today. Fun fact. And also, I really like BSides. As Karen said, it was the first place who gave me a chance to speak here today. Here's like live footage from the Turkish hammam we had for the first BSides, with Inbar even next to me on stage. It was, you can't even imagine how we got like so much further. Okay, so what is fingerprinting? Let's start with speaking about fingerprinting. Not even in the context of any like technical stuff, but just like fingerprinting 101. We want to positively identify an object by collecting properties. We can do it actively, like asking questions like, hey, what's your name? Or can you show me an ID? This will allow me to identify this object, right? But we can also do it in a passive way. I can, for example, eavesdrop and overhear maybe those two girls speaking with each other and then overhear the name of one of them. And by that, I might be able to identify one of them. But we are not here doing CSI or even CSI cyber, God forbid. We are speaking about technical stuff. So let's proceed and see how this concept takes part in the world of web. So I guess that most of us already written at least like a couple of Python lines which perform a HTTP request, fetching resources from the web. And you know that client's implementation varies. You know, every one of us can write different code, different languages, different implementations, different errors maybe. It just varies. And also, the infrastructure level, you have different OS operation systems. You have different network devices. All of those might have all kinds of impact on the fingerprint that you have. We'll see examples like much later in this talk. Do remember that some of those are by design. For example, user agent. User agent allows the server to serve you with content which might be better suited to your device, like if it's a mobile device of some kind. So it might allow you to do this kind of stuff. But And some of them are not by design. Those are side channels. For example, different browsers return different errors, or they pass different stuff a bit differently. They have different implementations for specific functionality, not going exactly by the RFC sometimes. It does happen. It is nothing new. It is being used. It's being used in the product I worked on in the area of the anti-bot industry, trying to detect bots by the fingerprint. For example, you know stuff like reCAPTCHA and this area. They use exactly those tactics we're going to see here today. And also in this like web fingerprinting technological kind of concept, you also have passive and active fingerprinting. Passive meaning that you only take the incoming traffic and sniff it and pass it and do whatever you want without actually altering the normal flow of network communication. And active, well, you might ask the server, or sorry, the client, can you execute this JavaScript for me? Or you might try and check which ports are open on the IP that is associated with the client. Okay, and if you want to see a bit more about these tactics, I really recommend this website, Am I Unique? It will show you a lot of those tactics. You can scan this QR code. There will be some QR codes throughout this talk, so feel free to do so. Am I Unique? Okay, fingerprinting. We know what's fingerprinting. We have some idea about web fingerprinting. But what are those link scanners? Or let's begin maybe with why. Why we need those link scanners. There's an actual email I received from the not so legit domain with the link there below, something with a TLD of XYZ. That's why we need link scanners, because links can be dangerous. So we need to check them before the user accesses those links, hopefully, and then alert and block. And if no one actually clicked the link and went to this malicious website, we win. As simple as that. No one actually accessed this phishing content or downloaded a malicious binary, so good for us. But where we can find those, and it is kind of surprising, but a lot of different products have this kind of component which fetches data from a URL. Not only link scanners, but there are a couple of those. For example, VirusTotal. There's a URL scanning capability in VirusTotal. There's also urlscan.io, which is amazing and highly recommended, at least from, in my opinion. There are also email security products. You have incoming emails. Incoming emails have URLs sometimes, like in my case. G Suite, Office 365, all have this kind of component scanning incoming emails for links and then tries to grab something which is behind this link. Sandbox solutions, also, surprisingly enough, you can scan a file and submit it from a URL, which means there's a client downloading this file into the machine somehow, automatically, like some people like to say. And even instant messaging platforms sometimes have a similar component for doing this kind of stuff. If someone which you don't know sends you a message with a suspicious link, it might get scanned. But, it is all very nice and fancy, but what's actually taking place behind the scenes? So there's content, HTML content, binary content, and we want to fetch this content somehow. How you fetch it? Usually HTTP request. We're going to speak today here about HTTP requests mostly. And how we do that? Well, you guessed it. The answer is always Python. Something like this. I am not familiar with the actual implementation of some of the clients for checking the security of links, but this implementation might be actual stuff which actually goes there behind the scenes. That's the best code in their opinion. They don't have security in their mind too much, as we're about to see. So, we know what's fingerprinting, we know what's web fingerprinting, we know what link scanners are and why do we have them. But how we can leverage this fingerprinting stuff to evade link scanners? Because that's our goal here today before trying to fix things later in the talk. So, I had a what-if moment. Link scanners are web clients, just like bots, just like browsers, just like anything which fetches content from the web. And web clients are fingerprintable because I know that from my day-to-day job. As I said, implementation varies on many different levels. So let's say I can identify those specific clients, and I can tell, oh, this client, that's not a victim. That's not a phishing victim. This guy or girl doesn't try to download my malicious file and execute it. That's an actual, like, I don't know, VirusTotal trying to scan my website. So this will allow me to identify this specific client and send back a very different response. Graphically, a bit of like a simplification, server, client, request, fingerprinting, and then I make my decision whether or not I want to send a benign or a malicious response. As simple as that. Now for the fun part. Let's go layer by layer and try to understand where the vendors did something wrong, see some very fundamental flaws which were across all the vendors I've checked, and some nice examples. We'll start from the top, from application level, and go as deep as even link layer. So application layer, my favorite HTTP, everything is so easy, nice and dandy. And here comes the thing which annoyed me the most. I've inspected 15 different vendors in my research, and the thing which most of them did wrong and really wrong was obsolete user agent. You're all running your machine, you have a browser, if you're living in the 21st century, and it's usually kind of up to date. Maybe you didn't update it, I don't know, a couple of months, maybe half a year. But what we've seen in our research is prehistoric Chrome. And when I'm speaking prehistoric, I'm speaking about Chrome 50-something, which is over 5 years old. Or even incredible stuff like Internet Explorer 8, or even Internet Explorer 6. I think that today in the crowd, we have people who are younger than Internet Explorer 6. And I'm kind of joking, but I'm not. It is like, even Internet Explorer 8 is over a decade old, just like to give you some reference. And my all-time favorite, VirusTotal. I don't know how many of you ever checked it, but when you scan a website with VirusTotal, there's a user agent. But that is the user agent that you get. Yes, the word VirusTotal is part of the user agent, and yeah. By the way, that's, I think, one of my favorite animations in this presentation. It is inexcusable to scan a website and check if it is malicious or not when you're saying to the website, oh yeah, I want to check if you have any malicious content. No. They're aware of that, by the way, at least for a couple of years. Some other header anomalies now. Squid proxy is a proxy solution for almost any proxy-related stuff you do. Everyone uses it, but it I think by default adds a via header. This header was added by a sandbox solution I've tested. It was fixed, by the way. But not only that it included this via header, which included, I don't know, Squid proxy, which might be suspicious but not necessarily associated with a security product. It included the entire path of the machine within the lab, like sandbox machine number 1 and like sub-lab number 3, or I don't know what, but it disclosed the entire topology of the lab in this header. Again, ridiculous, but it is what it is. Also, another one of my favorites. One of the largest email security vendors had this refer header. Kind of trying to explain it. They synthetically added this header, which means to the website you browse into that somehow you've found exactly the name of the link, somehow magically in Google. I don't know how. And from Google, after searching for exactly this URL, you reach to the potentially malicious website. No one actually ever looks for HTTP, whatever, it doesn't happen. Moreover, if you're clicking on an Outlook link, like in the desktop version of Outlook, there's no referrer header at all. So even the presence of this header is a telltale of something fishy is going here. It was fixed as well, by the way. Let's go a bit deeper. So if we've been so far in the application layer, we'll go a bit deeper now to transport, internet, and link layers. All of them are a bit more technical. I won't dive too deeply into them, but let's give it a go. So there's an entity called AS, or ASN, Autonomous System Number. It has something to do with a protocol called BGP. Very large entities reside within this protocol, like ISPs or enterprises, for example. But what if those enterprises are security companies, like, I don't know, Kaspersky, Palo Alto, Akamai, I don't know. Almost every large enterprise have an AS for its own. So let's say that the IP range which is associated with this entity is the one scanning my server. It is just like, again, a very distinct telltale that I should never respond maliciously. You know, why should I, as someone who's trying to run a successful phishing or trying to kind of spread malware, send for free my content to the security vendor when it is very simple to know, like, to distinguish this association with the security vendor? Also, there are many security, cloud providers. Every cloud provider actually has their own AS. Google, Azure, like Microsoft, AWS, Amazon, and DigitalOcean, you name it. All of those are also, again, a very good indicator for someone who's running some machines in the cloud. Our victims are almost never. You know, how many of you are using a cloud machine as their day-to-day, daily driver machine? I guess that's none. Which means for an attacker, if it is a cloud machine, don't attack it. Next, some examples. You see this? This is what you'll see when you're hovering on top of an Office 365 link. By the way, it is all mangled. I've switched a lot of stuff, so don't try to copy-paste it and type it manually. You'll only waste some time. And just before you click it, of course, at Microsoft, we'll check whether or not it is malicious, right? But how? It will send an HTTP request from this IP, which surprisingly enough resides within Microsoft address space. So, yeah, I don't have a lot of motivation to send malicious content back to Microsoft. I know that my victim won't browse to me through Microsoft. And by the way, they also had this user agent. Chrome 79 is not that old, but it is about a year and a half old. Today we're Chrome 91 since May, so they might need to update it. And also an interesting idea. So they have Windows as part of the user agent. What if the target is an Apple user? If I have some intelligence about, you know, this organization, I know they have a lot of Macs. So I expect the request to come from something with a Mac user agent, not a Windows user agent. I will never respond maliciously to this user agent, right? And another tricky one, DNS PTR record. We all know DNS, mostly the A record, which is the one which returns to you when you're doing a DNS query, like, what's the IP address of google.com? PTR record is the opposite of it. It's what you get when you're doing the reverse DNS query. Again, with this nice animation, let's say you get a request from the IP elite. You send a query, which might be as simple as DNS Lookup, trying to figure out what's behind this IP. Surprisingly enough, you get the corporate's homepage or a scanner kind of URL. It actually happened to me twice. And then you can decide how you want to respond. But It allows you to identify, again, association of an IP with a security product. Really easily. All you need to do is NS Lookup. That's, by the way, one of the cases I had it. It is a bit redacted, but it was actually, I think, partially fixed even. But when you see it, you have a web page with like the sole purpose of checking whether or not a URL is safe or not. And they're probably checking it from the same machine, running both the UI and the actual module, running the link scanning activity. So easily detectable. When you run this NS Lookup thing, you'll get the URL of this web page. Like, come on. And they don't think it is a product. It's a problem, by the way. I worked really hard to convince them it is a problem. Another nice case. So yeah, I had a request from this IP with this user agent. Remember OS X 10.6. We'll go back to it in a sec. So it is trivial to find that this IP is associated with the AS 44444 force point 5 times 4. But also, if you do this NS Lookup trick, you'll see it is associated with something which ends with mailcontrol.com. What's mail control? It sounds a bit like a mail security thingy. I did Google, and it is associated with WebSense, which was merged into ForcePoint, etc. So again, this PTR record discloses the fact that this IP is something you don't want to respond to. More even, you can maybe scan the entire IP address space in this area and find more mail control systems, just like doing brute force DNS queries or something. And remember this 10.6? So Mac OS X 10.6 is also a decade-old OS. Who's running a decade-old Apple OS X on their devices? No one. It makes absolutely no sense. Again, inexcusable. Do some, I don't know, DevOps stuff. It is a couple of Python lines to automatically update this stuff to something which is at least reasonable to some extent. But is it all purely theoretical? And here's the answer. I promised cheap animations. This is taken from a real phishing kit. And the first few lines is get host by address. It's PHP, which sucks, but we can kind of understand it. It will actually do something which is equivalent to NS Lookup, and will check for stuff in a blocked words list, like Sucuri.net, which is a Brazilian firm doing mostly URL-related stuff. That's exactly what I suggested to do with the DNS PTR method. Also, you have similar checks for some ranges of IPs and some user agents. All can be found in a gist, which is available in the URL in this QR code. Again, you can check it out on your own. Very simple. Surprisingly enough, I saw it only on phishing kits with very little similar stuff in the world of Trojans and banking Trojans, etc. Let's go even deeper now. TCP, link layer, maybe a bit of IP. Protocols which are much more oriented in transmitting data between two clients efficiently, reliably, trying to maximize the number of bytes you can transmit without losing any. It is tricky, it is complex. I won't dive into TCP too deep now, but you need to have some understanding of the protocol, and some of its flags at least. And the number one reason to use this type of fingerprinting is OS detection, because if I know that I have a user agent of, let's say, Windows, but the TCP fingerprint is more like seemingly associated with, let's say, Apple-related OS, it is fishy. So TTL between Windows and the other two operation systems is different. That's kind of well known. It's even IP, not TCP. But also Windows size, for example. It is very similar and even identical in most cases between modern Windows devices and Apple devices, but in Linux, it is all over the place. So it allows you to have some kind of understanding what's the operation system. Really easily, or not that easily as we're about to see in a sec. Also, you have other stuff like MSS, which is, if you add 40 bytes, it is the same as MTU, a size which should prevent fragmentation. I have 45 minutes for my talk, right? Yeah. Just making sure. So, MSS and MTU, it is something which should prevent fragmentation in packets sent within your network. Different mediums have different limitations. All kinds of clever engineers try to optimize the size of packets, and you have this value. It is different between different mediums. Maybe you're going to see some value which is an outlier associated with VPNs, or some cloud vendors have a very distinctive MSS. This should be very interesting, and this might allow you to identify something which is wrong with the client. Maybe this will allow you to identify it as a bot. And this is why TCP stuff is not that simple. That's me sniffing Wireshark of me sending random packets over the wire. It is a nightmare to go through all of those fields and trying to identify what's exactly happening there. But this is why we have this incredible thing called POFF. Again, open source tool available in this link in the QR code. It has tons of different signatures for TCP-related stuff, like window sizes and MSS and much more flags, which I won't even get into today. It is so easy to use, very nice piece of code. Even it has like very, very exotic stuff, like, did you know that Google had a very specific MSS value of 1470? Maybe there was a PhD candidate or something doing research for Google, optimizing by 0.7%, like the efficiency of their network by manipulating this value. But it is a very, very strong hint that you're actually facing a Google-related machine right now. Very interesting. And you can, by the way, test all of it with PSTF², Passive Security Tools Fingerprinting Framework, an open source tool I wrote for this purpose, again available in this link. It is fully Dockerized, really easy to use. It's just like a fancy HTTP server. I customized a bit. It includes fingerprinting for all of the different layers I've mentioned so far. And also, it is easily extendable. Lots of configuration files available in YAML. I really enjoyed working on it. OK. So we've spoke about fingerprinting, web fingerprinting, and we've even spoke about what's link scanners and how we can circumvent them using fingerprints. But what's next? I don't know how many of you are familiar with this lovely video of Steve Ballmer, but in that spirit, I'll just go protocols, 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 because that's the future of this area of research. Know your protocols, and you'll have much more knowledge. I've actually inspected 15 different vendors, as I mentioned, in my research. And I wasn't required to go that far because I was able to evade detection from any of them. But they might catch up one day. So go and learn new protocols and see whether or not there's an opportunity in this area. There are a lot of existing papers by Akamai in this area. I highly recommend going through them. There's a nice research from 2017 by Elad Schuster and Ori Segal about one protocol. There's also a really nice page called Cipher Stunting. I highly recommend reading it too. Those are areas which should be explored if you want to improve your knowledge and about protocols which might be usable. And the funny thing is that actors are actually more aware of those protocols than security vendors. If I need to fingerprint today an actor which is writing a bot, it will be actually more difficult to me to fingerprint him than to fingerprint a security vendor writing something which should fetch HTTP, content over HTTP. Actors are way ahead of security vendors in that regard. Or maybe we should go active. But we've said it is noisy, right? So what about semi-active or maybe we should call it active by proxy or semi-passive. What if I have a subscription for Shodan, for example, and I proxy my request to check whether or not this client is kind of suspicious or not via Shodan or any other equivalent service. I'm not sending any direct request to the client. I'm just querying Shodan's offline existing database, which should be kind of accurate and might be interesting. For example, I might see parameters or open ports which are not typical to Windows machine, which this client tries to look like. And I won't be active in an active way. I'll just be active by proxy. Shodan will be active, but not me. So far, we've been a bit kind of pessimistic. But how we can get better? We're trying to fix stuff, not only to break stuff, right? Sadly, most of the stuff you've seen here today will allow you to detect any tool scanning URLs. I've reported it to so many vendors. Most of them fixed at least some of the stuff. One of them actually had some legal threats against me, which is a funny thing. But yeah. But how we can make those stuff better? Let's try to be actionable. First, learn your fingerprint. Run my tool, inspect it, and try to understand your fingerprint or your footprint. Whether you're a vendor or a blue team, know your limitations, know how you can be spotted. And more importantly even, manage your kind of footprint by trying to understand the level of effort for a red teamer to detect you or for a blue teamer to fix this issue. For example, free fixes. You're a blue team. You should never have a user agent which is over a couple of months old of the link scanning components in your system. Any of your systems, any of your modules, it should look like a human, not like a security product. I think it is given, but as it turns out, it is not. On the other hand, some stuff are more expensive, like going through proxies all day long. So yeah, it kind of sucks that Microsoft scans you from their own IP range, but is it actually feasible from the financial point of view or technical point of view to exit from residential proxies all day long? They need a data plan maybe, which is huge, and they might be forced into reusing proxies, which is very interesting. Maybe it can lead to them being detected. So it is not that easy to exit from different proxies. And also, there's this area of bad practices. You should never disclose the internal structure of your lab by misconfiguring headers. If you've even inspected the outgoing HTTP request once, this would never have happened. Just like you know your tools, manage your stuff, it makes no sense to just forget about it. And yeah, let's have a PTR record which associates our link scanner IP with the homepage of the company, which was, in some cases, the homepage was so obsolete that it never existed for the last 5 years. I was able to find it on Wayback Machine, but it was so obsolete that there was no homepage it referred to. It was just like a PTR record that they might have forgot about years ago. That's negligence. On the other hand, understand that TCP is a challenge, and not everyone knows how to operate POFF and to do all of these correlation shenanigans. You've seen phishing kits. Phishing kits don't use it. They don't need to, but it is also possible that they simply can't. You have script kiddie and knowledgeable people. You're trying to at least be better than some. So maybe try to balance between the stuff you can and should fix, like user agents, for example, and other stuff which are much more tricky. To conclude, and this is a picture of my cat again, just to grab your attention in case you fell asleep. We know what fingerprints are. We know what web fingerprints are. We know what link scanners are. We know how we can evade them now. We also know how you can facepalm when you see all of the different fails of vendors. And we've seen some potential stuff for the next big thing in this area. And also, we try to fix some stuff. And I don't think we have time for questions, or do we have? Or I don't know. No? Yes? No? Okay, no.